Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hey everyone, and welcome to the Microsoft Azure Data Fundamentals Virtual Training Day. I'm so excited to have you all here, and I hope you're ready to dive into the amazing world of data with me. I'm Krista Santos, your Microsoft technical trainer for this journey. Over the next few sessions, we're going to break down some super important concepts around data and the Azure services that bring it all together. Now, my main focus for this Data Fundamentals Virtual Training Day is simple. I want you to walk away feeling confident about data, what it is, how it works, and how you can use Azure to manage it. But don't stress about becoming an expert right now. Today is all about understanding the why and the what behind these technologies. Plus, we're going to get hands-on with them, so you'll actually see how everything works in real time. Let's take a look at what we have planned for this Data Fundamentals Virtual Training Day. We have 6 exciting sessions planned for you. We'll kick things off with sessions 1, 2, and 3, where we'll break down the core data concepts you'll need to know, focusing on relational and non-relational data in Azure. Once we've got the core concepts down, we'll move into sessions 4, 5, and 6. This is where we will dive into large-scale data analytics, real-time analytics, and data visualizations. By the end, you'll have a solid grasp of how to transform raw data into valuable insights. All right, enough intro. Let's dive into session 1 and kick things off by exploring the fundamentals of data. What is data? Why does it matter so much? And how does Azure come into play when managing it? Let's get started and find out. All right, let's jump right into some core data concepts by tackling a seemingly simple but big question. What exactly is data? Data is the heart and soul of every information system. It's the fuel that powers everything we do with technology, whether it's numbers, descriptions, or observations. Data is how we capture, store, and make sense of the world around us. But here's the thing. Data isn't just some random collection of facts floating around. It's carefully organized into structures that represent meaningful elements or entities that are crucial to any business or organization. Think of data like a puzzle. Each piece represents an entity. And when you fit those pieces together, you get a complete picture of what's going on in the business. And just like in a puzzle, each piece, each entity has specific details that define it. When I say entities, I'm talking about the building blocks of an organization. These could be customers, products, orders, whatever is core to the business. Each entity has attributes, which are characteristics that describe it. For example, if we're talking about a customer, their attributes might include their name, their address, phone number, basically all the details that help us know who they are. Similarly, for an order, you might track the order date, the total amount, the customer who placed it. And hey, without these attributes, working with data would be like trying to put together a puzzle without knowing what the picture is. It's possible, but it's going to take a lot of guesswork. By organizing data into these entities and their attributes, it's like putting together that puzzle. Businesses get a clear, complete view of their operations. This structure allows them to understand how everything fits together, make sense of complex relationships, and make faster and smarter decisions. Now that we've got a handle on what data is, let's talk about the different flavors it comes in. Generally, data can be grouped into 3 main categories: structured, semi-structured, and unstructured. Think of it like organizing your closet. Some things are neatly folded, others are a bit mixed up, and then there's a pile of stuff you're not quite sure what to do with. Structured data is the most organized form of data. It follows a consistent format that makes it easy to store, retrieve, and manage. Think of structured data as a well-organized system where everything is neatly arranged according to a predefined pattern, like a filing cabinet. In this filing cabinet, each drawer represents a different category of information, and within each drawer, folders are labeled clearly, making it simple to find exactly what you need. For example, imagine a filing cabinet in an office where each drawer represents a specific type of record: customers, orders, or products. Within the customer drawer, each folder contains the information of an individual customer, neatly separated by categories like name, address, and phone number. This setup ensures that every piece of information is stored in a predefined format so that when you need to look up the details about a customer, you know exactly where to go and what to expect. Now, say you want to find all orders placed by a specific customer. You'd first pull up the orders drawer and find the relevant folders, which are linked back to the customer's details using a unique identifier, like a customer ID number. The filing cabinet analogy shows how structured data keeps everything neatly organized, allowing you to retrieve information quickly and efficiently. In the digital world, structured data operates just like this filing cabinet. Every bit of data fits into rows and columns, just as it fits into folders. This structure makes it incredibly easy to search, sort, and analyze data with minimal effort. Whether you're handling thousands of customer records or managing inventory for a retail store, the structured approach ensures that everything is in its right place, ready to be accessed when needed, just like flipping through well-labeled folders in a perfectly arranged filing system. Now let's move on to semi-structured data. Unlike structured data, which fits neatly into predefined rows and columns, semi-structured data doesn't follow a strict format, but still retains some level of organization. Think of it like a filing cabinet where folders aren't always organized the same way, but there's enough structure to find what you need. A great example of semi-structured data is a JSON file, commonly used in web applications. Imagine opening a folder labeled Customers in our filing cabinet. For one customer, the folder might contain their name, 2 phone numbers, and an email address. For another customer, the folder might have a name, a single phone number, while a third folder might be missing a phone number entirely. Despite these differences, everything is still stored in a way that's organized and easy to retrieve. The beauty of semi-structured data is its flexibility. It can adapt to varying amounts of information without needing every record to conform to the same format. This is especially useful in situations where structure of the data is constantly changing. For example, an e-commerce platform might use JSON files to store customer details, product catalogs, and transaction histories. One customer might have several orders and multiple shipping addresses, while another customer might have made only one purchase and provided a single address. In this case, our filing cabinet allows for different folders with different contents, but there's still enough structure to keep things manageable. The adaptability of semi-structured data means it can accommodate both standard fields and optional ones, making it ideal for dynamic environments where data evolves over time. Lastly, we have unstructured data, the most free-form type of data with no predefined format or structure. If we continue with the filing cabinet analogy, imagine you've got a drawer full of random items, loose papers, photos, videos, handwritten notes, and even voice recordings. Nothing fits into neatly labeled folders or follows a standard template, yet each item holds valuable information. Unstructured data can take many forms, such as text documents, emails, images, videos, or audio files. Picture a digital archive filled with product photos, customer reviews, and video testimonials. These may not follow a structured format, but they still provide important insights. For instance, a video testimonial from a customer or a product review can tell you a lot about the customer's satisfaction and preference. Social media posts, email records, and customer support chat logs are also examples of unstructured data. The challenge with unstructured data is that analyzing it requires advanced techniques. For example, to make sense of text-based data like emails or social media comments, we might use natural language processing. Similarly, image recognition technology helps analyze visual content such as photos and videos. While unstructured data is more complex to work with, it often contains a wealth of insights that, when properly analyzed, can drive smarter business decisions. Now that we've explored the different types of data, it's time to dive into how this information is stored. Depending on the type of data, whether it's structured, semi-structured, or unstructured, there are specific storage solutions that are best suited for each. However, there are also versatile storage systems that can accommodate more than one data type. For structured data, one of the simplest storage methods is delimited text files, like CSV files. These files arrange data in rows and columns, making it easier to read and manipulate. For example, an inventory management system might use a CSV file to track product names and prices and stock levels. But as data becomes more complex or grows in volume, CSV files may not be enough. That's when other advanced storage systems come into play. For semi-structured data, JSON is one of the most common formats. JSON is lightweight and easy to use, especially in web applications. For instance, if you're building a web app that collects customer data, JSON would allow you to store this information in a flexible format, supporting different numbers of attributes for each customer. JSON is also commonly used in APIs to exchange data between systems, making it a versatile choice for many modern applications. Another format you might encounter is XML, which is particularly useful in industries that require strict data formatting, such as finance or healthcare. XML allows for hierarchical data storage with tags that describe the data, making it useful for scenarios where data integrity and structure are paramount. For instance, healthcare organizations often use XML to store and transfer patient records between systems, ensuring that data is easily readable across different platforms. Now, when working with large multimedia files such as images, videos, or audio, you'll often use blobs, which stand for binary large objects. Blob storage is specifically designed to handle massive files that can't be easily stored in traditional relational databases. Think of it as a space for all those high-quality videos, photos, or audio files that need to be accessed quickly without sacrificing quality. For example, imagine a video streaming service that stores movies and TV shows. These files would be stored as blobs, allowing the service to deliver content seamlessly while ensuring the data is available in the highest possible quality, even at large scales. Blob storage is like the ultimate digital vault for all those giant media files, ready for fast retrieval whenever you need them. For handling massive datasets, especially in big data environments, optimized formats such as Avro, ORC, and Parquet are your go-to options. Avro is a row-based format excellent for data serialization and storage, particularly when systems need to exchange data because it includes both the data and its schema. This makes it highly efficient for writing data or serializing it for fast transmission between systems. Parquet, on the other hand, uses a columnar storage format where data is stored in columns instead of rows. This makes Parquet especially powerful for analytical workloads, where you need to query specific columns rather than the entire dataset. Lastly, ORC, or Optimized Row Columnar, is also a columnar format like Parquet, but often provides better compression and faster query performance for specific types of queries. Originally developed for Hadoop, ORC is widely used in big data applications. Next, let's talk about databases, the backbone of data storage. There are two main types of databases, relational and non-relational. Relational databases are ideal for structured data. They organize information into tables, with relationships between tables established using keys. Think about a banking system where every account, transaction, and customer is recorded. Relational databases ensure that all this information stays accurate, consistent, and easy to retrieve. Their structure makes them especially reliable in scenarios where consistency is critical. Now, non-relational databases or NoSQL databases offer much more flexibility. Instead of tables, they store data in various formats, including documents, key value pairs, and graphs. Graph databases are particularly powerful when dealing with highly interconnected data. A great example is a recommendation engine. Think of how streaming services or online retailers suggest movies, music, or products that you might like based on your preferences and behavior. Graph databases map out relationships between users, items, and preferences, making it easier to recommend new content or products based on those connections. Take social media platforms, for instance. Users post text, upload photos, share videos, leave comments, all of which are unstructured or semi-structured data. Non-relational databases excel at handling this kind of varied and interconnected data. When we think about how we use data in everyday systems, it typically falls into two main categories. First, we use data to support real-time operations, where everything needs to happen instantly. Then there's data analysis, where we process and analyze large amounts of data for insights and decision-making. Let's start with real-time operations. This is where OLTP systems or online transaction processing comes into play. These systems are designed to handle fast, high-volume transactions in real time. Think about it. Every time you place an order online, transfer money between accounts, or even book a table at a restaurant, the system needs to instantly update everything from inventory to payment details to availability. That's what OLTP systems are built for, ensuring that transactions happen quickly and accurately. What makes OLTP systems so reliable are the ACID principles, a set of rules that ensure every transaction is handled safely and efficiently, no matter how fast things are moving. Let's break them down. First, there's atomicity. This means that every transaction must be fully completed or not completed at all. Imagine transferring money between two accounts. Both accounts need to update at the same time. If something goes wrong, the entire transaction will fail, preventing any partial updates and ensuring consistency. Next is consistency, which ensures that the database always remains in a valid state. Any changes made by a transaction must follow predefined rules and constraints, so the data is always accurate and trustworthy. Then we have isolation. Even if multiple transactions happen at the same time, they don't interfere with each other. For example, if two users are trying to update the same record simultaneously, the system keeps those transactions separate to avoid any conflicts or errors. Finally, durability guarantees that once a transaction is committed, it's permanent. So even if there's a system crash or power outage, the completed transaction will still be there when the system comes back online. Now let's walk through the process of how operational data moves from raw form to being used in analysis and decision-making. Imagine you're running an e-commerce business. Every day, your systems are collecting data on customer orders, website interactions, and inventory levels. This is operational data, raw, unstructured, and coming in from multiple sources. First, this operational data is extracted, transformed, and loaded into a data lake. The data lake serves as a central hub where all this raw data is collected and stored for future analysis. Next, the data is organized into a schema of tables. This can happen in two ways, either through a Spark-based data lakehouse, where data is stored in files but accessed through tabular abstractions, or in a data warehouse, which uses relational SQL engine to store and manage data in a more structured and table-based format. For example, data about customer purchases, product details, and sales figures can be neatly organized here. Once the data is in tables, it can be aggregated and loaded into an OLAP model or cube, which allows for powerful, efficient analysis. This step is crucial when you want to understand trends over time. For instance, you might analyze how sales in one region compare to another, or how a specific product category has performed over the last year. Finally, whether you're working with files in the data lake, relational tables, or an OLAP cube, all this data can be queried to produce reports and dashboards. These tools give you a real-time view of your business performance, such as customer behavior, top-selling products, and even inventory forecasts. This is the data that helps inform strategic decisions like adjusting marketing campaigns or optimizing stock levels. So let's move into our next lesson in this module: data roles and services. In the data world, there are many roles, each playing a vital part in managing and analyzing data. While we won't cover every role here, like data architects who design the overall architecture of data systems, or data scientists who focus on advanced analytics, we'll focus on three of the most common and essential roles today. First up, we have the database administrators, or DBAs. These professionals are responsible for ensuring databases run smoothly. They monitor performance, manage database security, and ensure proper backups are in place. DBAs are also tasked with managing user permissions and making sure that sensitive data is protected from unauthorized access. For instance, in a financial institution, a DBA might ensure that the customer account data is encrypted and only accessible to authorized personnel, maintaining the highest level of data security. Next, we have data engineers. Data engineers are the builders of the data pipeline. They design, create, and maintain systems that collect, store, and process data. A key responsibility for data engineers is handling the ETL process, which stands for extract, transform, and load. This involves extracting data from various sources, cleaning and transforming it into a usable format, and loading it into databases or data warehouse. For example, a data engineer in healthcare might create a pipeline that extracts patient data from multiple hospitals, standardizes it, and loads it into a centralized database. This ensures that all patient data is ready for analysis and easily accessible. Finally, we have the data analysts. The data analysts play a crucial role in transforming raw data into actionable insights. One of their key responsibilities is data modeling, which involves structuring and organizing data in ways that make it easier to analyze. They also create reports, dashboards, and visualizations that help businesses understand their data. For instance, a data analyst in a marketing department might model customer data to understand which products are performing best among different demographics. Using this analysis, they can help company make more informed decisions about marketing strategies and product development. As we wrap up Module 1, let's briefly touch upon some of the Microsoft Cloud services that can help you manage, store, and analyze data. For operational workloads, we have services such as Azure SQL and Azure Cosmos DB. Azure SQL is a fully managed relational database service that offers high availability and automated backups, keeping your data secure and always accessible. Azure Cosmos DB, on the other hand, is a globally distributed NoSQL database built for high performance and scalability, making it perfect for applications that require fast, real-time data access across multiple regions, especially when dealing with diverse data models. On the analytical side, tools like Microsoft Fabric provide a unified platform for integrating multiple data sources and performing analytics without heavy infrastructure. And for advanced big data processing and machine learning, Azure Databricks offers a collaborative environment that excels at building complex data pipelines and running sophisticated models across large datasets. Of course, this list isn't exhaustive. There are many more powerful tools and resources within the Microsoft Cloud ecosystem, and we'll be diving deeper into those in the upcoming modules. And with that, we've officially wrapped up Session 1. We've covered the basics of data classification, explored different types of data storage and data workloads, and discussed the key roles involved in data operations. Now, let's take a 10-minute break and take this opportunity to stretch, recharge, grab a quick drink or snack. When you come back, we'll dive into our second session where we will explore relational data in Azure. See you soon. Welcome back. I hope you've had a chance to stretch, recharge, and maybe grab a quick snack. Hopefully you didn't get pulled into any work during your break. In session 1, we laid the foundation of our data journey, covering the essentials of data management, key roles, and Microsoft Cloud Services. Now we're ready to kick things up a notch as we dive into session 2, where we'll explore the fascinating world of relational data in Azure. We're going to break down the core principles of structured data and databases and cover the power of relationships within data. This will give us a solid understanding of how to effectively organize and manage data in a way that drives smarter decisions. Let's kick things off by getting familiar with relational tables, one of the core pieces that makes relational databases so powerful. In a relational database, data is organized in tables, which you can think of as spreadsheets. These tables are made up of rows and columns. Each row holds a unique piece of information, like a customer, a product, or an order. And every row in the table follows the same column structure. These columns define the attributes or characteristics of the data. For example, in a customer table, you'd have columns for the first name, last name, and email address. Now here's the flexible part. Not every column needs to have a value. Let's say there's a middle name column for our customer table. It's totally fine for some rows to leave that blank or to have what we call a null value, meaning there's simply no data provided for that particular piece of information. Each column is also designed to handle a specific type of data. So for example, an email column would store text, which could vary in length depending on the email address. On the other hand, a price column in a table would store decimal values for currency, while a quantity column in an order table would be set to store integer values. And we can't forget about the date and time. An order date column in the order table would be designed to store date time values, making it easy to track when orders were placed. It's worth mentioning that different database systems may have slight variations in data types they support, but most systems follow a standard set of data types established by the American National Standards Institute, also known as ANSI. So no matter what system you're working with, you can rely on a pretty consistent set of rules when defining your tables. Now I want to shift our focus to something crucial in the world of relational databases: normalization. Think of it like mastering the art of organizing your data for maximum efficiency. It's all about cutting down on the clutter and making sure your data is crystal clear and accurate. Let's start with a simple example. Imagine a company is using a spreadsheet to track its sales, and in that sheet you see customer details, product information, and prices all repeated for every single sale. The same customer's name and address appear over and over again alongside the product names and prices. It's messy, repetitive, and leaves a lot of room for mistakes. This is where normalization comes in. When we normalize data, we transform that chaotic spreadsheet into a well-organized system. Instead of stuffing everything into one table, we break the data down into smaller, more focused tables. For instance, we'd have a separate table for customers, products, and sales orders and line items. Each table would store just the relevant details, like the customer's name, the product's price, and so on. But here's the real magic. Each of these tables is tied together using something called a primary key. Think of it like a unique ID for each entry. So instead of repeating a customer's details for every order, we store the customer's ID in the sales order table, and that ID links it back to the customer's table where their full details are stored only once. Need to know a customer's address for an order? No problem. Just look it up using their customer ID. This approach keeps your data clean, organized, and efficient. One more important thing: referential integrity. It's like a built-in safety net for your database. Whenever you enter a foreign key, say the customer ID in an order, it has to match an existing primary key in the customer table. This prevents mistakes like trying to place an order for a customer that doesn't exist. Now that we've got a solid understanding of how relational tables are structured and how we optimize them through normalization, let's dive into the fun part, how we actually interact with relational databases. The language we use for this, it's called SQL, or Structured Query Language. But SQL isn't just any language. It's the universal communicator for your data. Think of it like a common language that all relational databases speak. And here's what makes SQL even more impressive. It follows a strict syntax set by the American National Standards Institute, ANSI, and the International Standards Organization's ISO. This means that no matter what database you're working with, SQL helps ensure consistency and compatibility. But there's a twist. While SQL provides a strong foundation, many relational databases have their own unique flavor of SQL, adding specific features and syntax. For example, you might have heard of T-SQL or Transact SQL for Microsoft SQL Server, PL SQL for Oracle, or PG SQL for PostgreSQL. Each of these has its own little tweaks, but at the core, they are all built on standard SQL. Now, you don't have to worry about all those variations right now. Let's focus on the 3 common types of SQL statements you'll encounter, each serving a distinct purpose in managing your database. First up, we have the Data Definition Language, or DDL. This set of statements is all about managing the objects in your database, like tables or any other object. With DDL, you can create, alter, or drop tables. For instance, when you use something like create table statement, like the example on the slide, you're creating a new table called products. Next, we have the Data Control Language, or DCL. This is all about controlling who has access to your data. With DCL, you can grant, deny, or revoke permissions for users or groups. For example, you could give user 1 permission to select, insert, and update data in the products table. And finally, we get to the Data Manipulation Language, or DML. This is where SQL really shines. It's all about interacting with your data. With DML, you can insert, update, or delete specific data in your tables. For instance, the example on the slide shows a select query that pulls product names and prices based on a specific condition. Now, keep in mind, SQL is a massive language. We've just scratched the surface here. If you find SQL intriguing and you want to dive deeper, there are some great resources out there like the DP080 course on querying data with Microsoft Transact SQL, or the Get Started with Querying with Transact SQL learning path on Microsoft Learn. But the key takeaway here, SQL is your go-to tool for managing, accessing, and manipulating relational data. Once you master it, you unlock the full potential of working with relational databases. Tables aren't the only important objects you'll encounter in a relational database. There are other few key players that help make everything work smoothly, like views, stored procedures, and indexes. Let's start with views. Think of views as your predefined SQL queries that return structured data sets, almost like virtual tables. You can query them using select statements just like you would any other table. Views are super helpful when you want to simplify complex queries or hide the complexity of underlying database structure. It's like having a shortcut that lets you focus on the data you need without worrying about the nitty-gritty details. Next up, we have the stored procedures. These are defined SQL commands that can be run on demand, almost like mini programs in your database. What's cool about these stored procedures is that they allow you to add parameters for flexibility in your data operations, like inserting, updating, or deleting records across your data entities. They make repetitive tasks easier and more efficient, allowing you to run complex data operations with a single call. And then we have our indexes. Think of these as the navigation guides for your database. They act like a roadmap for your query engine, helping it quickly find the data it's looking for based on specific column values. By speeding up data retrieval, indexes make your database operations more efficient, especially when dealing with large data sets. Together, views, stored procedures, and indexes, and other objects all work behind the scenes to create a robust and efficient relational database. They empower your applications to securely manage, store, and retrieve data with ease, and they play a crucial role in how we interact with and manage our data. Now that we've covered the concepts behind relational databases, it's time to see them in action. This is the moment you've all been waiting for. Let's dive into some of the Azure resources designed specifically for relational data. First up, we have the original Azure SQL. Azure SQL is a family of services built on the solid foundation of Microsoft SQL Server, one of the leading relational database management systems trusted by some of the world's largest organizations. While SQL Server is widely used for on-premises solutions, Azure SQL brings all that power and reliability to the cloud, offering flexible solutions for just about any scenario. Now, Azure SQL comes in 3 different flavors, each tailored to specific needs. First, we've got SQL Server on Azure virtual machines. This is like having your own virtual database server in the cloud. It's perfect for projects where you need full compatibility with existing on-premises SQL Server setups, or for hybrid environments where you're combining both cloud and on-premises databases. It's the go-to choice if you want full control of SQL Server, but in the cloud. Next, we have Azure SQL Managed Instances. This is a platform as a service or PaaS solution that automates many core administrative tasks, making it ideal for migration scenarios. If you're looking to move your on-premises SQL Server databases to the cloud with minimal changes and without worrying about managing hardware, this is a fantastic option. It gives you the flexibility of SQL Server, but with a lot of heavy lifting taken care of. And finally, we have Azure SQL Database, which is another PaaS solution and probably the most cost-effective option out there. It's perfect for new applications that need a low-cost relational database with minimal administrative overhead. If you're looking for a simple, scalable option without needing to worry about managing infrastructure, Azure SQL Database has you covered. Now, here's a handy tip to keep in mind. The options we've covered are arranged in decreasing order of administrative control and cost. SQL Server on a VM gives you the most control, but also comes with higher costs. On the flip side, Azure SQL Database offers the least control, but it's the most budget-friendly choice. But don't think you're limited to just Azure SQL. Open source databases have become a cornerstone of modern technology because they bring a lot to the table: flexibility, cost efficiency, and innovation. And Azure has fully embraced these open source powerhouses to give you even more options to choose from. First up, we have MySQL, a friendly open source database management system that's incredibly popular thanks to its simplicity. You'll often find MySQL in the LAMP stack applications, working alongside Linux, Apache, and PHP. It's a go-to for developers who want a straightforward, reliable database solution. Next is MariaDB. Fun fact, MariaDB was created by the original developers of MySQL. Over time, it's been optimized for even better performance, making it a strong contender. One cool feature of MariaDB is its compatibility with Oracle databases, offering you even more flexibility in your database management. And finally, we have PostgreSQL. Now, PostgreSQL is a bit of a hybrid. It's part relational database, part object database. What sets it apart is that while you can store data in traditional relational tables, PostgreSQL also lets you work with custom data types, offering you flexibility that goes beyond conventional databases. It's a real game changer when you need more than just the basics. All right. We've talked a lot about databases, so how about we get some hands-on practice with Azure SQL databases? Let's log into the Azure portal and get started. All right, so here we are in the Microsoft portal, and this is where we are going to be doing our demo today. In order to create our relational Azure resource, we're going to click the Create a Resource button, and we're going to search for Azure SQL. Now, the first item in the marketplace is going to be the one that we're looking for and the resource we're going to be creating. So I'm just going to select the Create button there. And we're going to be focusing on SQL databases, but we also have SQL managed instances and SQL virtual machines. But for this demo, we'll be focusing on SQL databases. The first thing we always do when we create a resource is add it to a resource group. And then we're going to give a database name. For this database, we're going to call it AdventureWorks. And then we're going to create a new server for this database. I'm going to call it Data Demos. We're going to add it to the West Europe region. And then we're going to figure out what kind of authentication we want to give this SQL Server database. We have three options: the Microsoft Entra only authentication, both SQL and Microsoft Entra authentication, or only SQL authentication. For this demo, we're going to use the last option, use SQL authentication. And I'm going to give an admin login here. And I'm going to create a password for this server as well. Now, we have to remember this password because we are going to use it later on in this demo to log into this server. All right, so now that we have created our server, we are going to make sure that our workload environment is development because this is just a demo. And also we're going to keep our compute and storage to the same default option, general purpose serverless. And for the backup storage redundancy, I'm going to shift to the locally redundant backup storage because I do not want to put it in zone or geo because that's extra backups, which we do not need for this demo. So when it comes to the networking part, I'm going to select public endpoint here so that I can connect from my browser into this SQL Server database. If I don't select this, then I will need to go through a private endpoint or create a virtual network through which I can get access for security purposes. But since this is a demo, let's keep it to a public endpoint. Next, we will go to the firewall rules. In the firewall rules, I'm going to make sure both of the options here are ticked to yes, because this is going to allow me to allow Azure services and resource to connect to this server. And also, I'm going to set up my current IP address to be accessible by the server. All right. So let's go to the next step, which is security. I'm not going to turn on the Microsoft Defender for SQL. I'm just going to keep it to not now. And then let's go to the next steps, which is additional settings, where I am not going to change much here, except I'm going to add a sample database in the use existing data part. So I'm going to select sample there, and it's going to add some data so that we have some data already to work with in our database. And with that, we are done with the configuration of the SQL database, and we can just hit review and create. We can see the estimated cost, which is $5.69 USD per month, and also the compute cost for any compute resources that we use. So vCore seconds is the unit we use here. So we can see all the settings and configurations we have set up and just hit create. So now in this deployment, we're actually deploying a SQL database, but we're also deploying a SQL server. So this is going to take some time. All right, so here is our resource successfully deployed. So let's go to the resource, and we can do that by simply clicking the Go to Resource button. All right, so here we have the SQL server name and the database name. Now, in order to query this, let's go to the query editor. And here I'm going to use the SQL Server authentication. Remember the password I told you we're going to use later? That's where we're going to put in the password to log in to this SQL Server. And here we are in the SQL query editor. And I can check my tables. I have a lot of tables because we pre-populated this with some sample data. And what I'm going to do is query that product table that we have here. So I'm going to write a very simple select query here. So select star from sales LT product. And let's run that. And you can see I get the results of this table. This is structured data, right? We have column names and we have rows, and we have a lot of columns here, right? And I can scroll all the way up and down to see all these columns, all these rows. But what if I want to see only a certain set of columns instead of all the columns? I can do that by just changing this query, right? So you can see I have all of these other columns here. And what I can do here is I can just add the column names that I want, like product ID, name, list price, and product category ID. I'm just going to put that from into the next line, and then I'm going to run this query. And now you can see I only have 4 columns. So if I open this up, you see I do not have any more columns showing up. There's no scroll bar available here, right? But instead of product category ID, what if I wanted to see the product category name? Now, this information is not available in this table. It's available in another normalized table that's available in my database called product category. So that's the product category table there. And so I'm going to create a join here to join these 2 tables so I can get that product category information. So I'm going to say join with my product category table. I will need to rename these tables so that I can reference them easily. So I'm going to call the first table P and the second table C. And then I'm going to put the condition of my join, which is on the column that both of the tables have in common, which is product category ID. So P.product category ID is equal to C.product category ID. I'm just going to copy that over there. Now that I've done this, the only thing left for this query is to use the reference in the column names, because if I don't use it, I will not know from which table I need to get these columns. So the product ID, the name, the list price, they all come from my first table, the product table. And my product category ID, I'm going to replace. But I'm also going to rename the product name column to product name, because I'm going to get product name and I'm going to get product category name. So that last product category ID is going to be renamed to category. So I'm going to call it c.name as category. And then I can run this query. And now you can see, instead of category ID, I have the actual name of my category, right? So this shows you how you can get that product category data into your product table doing a very simple join. And these are entities, right? So these are normalized entities to reduce the redundancy of having all the category information repeated in our product table. We create a separate product category table that is normalized and has each category mentioned only once instead of each category information showing up multiple times. And through a join, we can slice and dice this data, slice our product data with our product category data. And with that, we have come to the end of this demo. That was a pretty cool demo of Azure SQL databases. What did you think about it? Hope it makes you curious to test it out yourself. With this demo, we've come to the end of session 2. We have learned about relational databases, how and why we normalize tables within them, and some SQL and other important database objects, as well as Azure services and services available for open source options. Great. Now it's time for another 10-minute break, and I'll see you refreshed and recharged for the third session where we'll see non-relational or NoSQL data in action in Azure. See you soon. Welcome back, everyone. I hope you had a refreshing break and are ready to dive into session 3. In this session, we're going to explore the fundamentals of Azure storage, which is the backbone of so many cloud solutions. But that's not all. I'm also excited to introduce you to Azure Cosmos DB, which is hands down one of my favorite Azure data solutions. It's a real game changer when it comes to working with globally distributed, high-performance databases. But before we get to Azure Cosmos DB, let's start with the basics and build a solid understanding of Azure storage. Now, do you remember what blob stands for from session 1? We know that blob stands for binary large object. And in Azure Blob Storage, we're talking about storing massive amounts of unstructured data or blobs in the cloud. Inside your Azure storage account, you can create these blobs within containers. Think of containers as handy folders where you can organize related blobs, kind of like how you organize files on your computer's hard drive. Now, what types of blobs can you work with in Azure Blob Storage? Well, there's a few, so let's break it down. First up, we've got block blobs. Imagine them as stacks of blocks, each capable of holding up to 100 megabytes of data. A single block blob can have up to 50,000 blocks, which means it can grow to a whopping 4.7 terabytes. These are perfect for storing large, unchanging files like videos. So if you're uploading cat videos in 4K, no judgment, block blobs are your friend. Next, we have got page blobs. These are organized into fixed-size 512-byte pages and are optimized for random read and write operations. Think of them as your go-to storage for virtual machine disks. If you need to run a virtual machine in Azure, page blobs are ready to store the data efficiently. Then we have append blobs. They are a bit like block blobs, but with one special feature. You can add only to the end. This makes them ideal for scenarios where you're constantly adding new data, like logging. So if you're storing a continuous stream of log files, append blobs are the way to go. Now, storing data is one thing, but often you also need to think about how often and how fast you'll need to access that data. Azure gives you access to 3 access tiers to balance speed and cost. First up, we've got the hot tier. This is the default choice for frequently accessed blobs that need to be super responsive. Think of it as a top-shelf, high-performance option. If you've got a web app serving up images for users, this is where you want your data instantly accessible with minimal delay. Next, we have the cool tier. It's a little slower, but much more cost-effective if you don't need the data as often. For example, if you're generating daily transaction logs that are frequently accessed at first, but less so over time, you can start them in the hot tier and later migrate them to the cool tier when they're not being used as much. It's a perfect way to save costs while keeping your data within reach. And finally, there's the archive tier. This is the lowest cost option available, but it comes with increased latency, so it's best for data you rarely need but must keep safe. Think of it like your long-term storage for historical data. Stuff you do not need now, but you might need for compliance or legal reasons. It's there when you need it, but not taking up extensive resources in the meantime. And if you're anything like me, as soon as you hear about these tiers, you're probably thinking, wouldn't it be great if this could just be automated? Don't worry. You can set up lifecycle management policies to automatically move your blobs from hot to cool and eventually to archive as they age. You can even automate the cleanup process by deleting outdated blobs. Pretty sweet, right? In the end, Azure Blob Storage gives you the flexibility and power you need to efficiently manage your unstructured data, no matter how big or how varied it is. Talking about Azure Blob Storage, another storage account comes to mind, Azure Data Lake Storage. This is a powerful service that's essential for managing and analyzing massive amounts of data in the cloud. If you're working with big data, this is definitely one service you need to know about. But before we dive into Gen 2, let's give a shout out to Azure Data Lake Storage Gen 1. Gen 1 was designed specifically for organizing data in analytical data lakes. Imagine a lake filled with all kinds of data, structured, semi-structured, and unstructured. Gen 1 helps you keep it all organized and accessible for analytics. It was built to be a solid foundation for handling large data sets and making sense of them. Now here's where things get exciting. Azure Data Lake Storage Gen 2 takes it to a whole new level. It's integrated directly into Azure Storage, bringing together the scalability of Azure Blob Storage and the cost-saving features and storage tiers and the hierarchical file system organization. It's the best of both worlds solution, and it's completely compatible with major analytical systems. So what does this look like in the real world? Let's say you're working with Azure HD Insights, a big data analytics service. With Azure Data Lake Storage Gen 2, HD Insights can mount the distributed file system hosted on your data lake and seamlessly process massive amounts of data. It's like having a powerful engine ready to drive all your data analysis. Or maybe you're using Azure Databricks, a collaborative analytics platform. Databricks can tap into Data Lake Gen 2 to manage and process large datasets efficiently, making it an indispensable tool for data scientists working with big data. Now I can almost hear you wondering, but how do I create a data lake with Azure Data Lake Storage Gen 2? Don't worry, I've got you covered. It all starts by enabling the hierarchical namespace option in an Azure storage account. You can either do this when you're creating a new storage account, or you can upgrade to an existing one to support Data Lake Gen 2. Just remember, the upgrade is one way, so make sure to plan carefully before making that change. Whether you're managing vast data sets or powering cutting-edge analytics, Azure Data Lake Storage Gen 2 is an invaluable tool. It's built to handle scale and complexity of today's data demands and help you unlock the full potential of your data. Next up, let's talk about Azure Files. And trust me, if you're familiar with traditional network shares, you're going to love this one. At its core, Azure Files mirrors that classic network share concept that you typically find in an on-premises setup. It's all about making files and documents easily accessible to multiple users. But here's the twist. No more hardware, no more maintenance headaches. Seriously, kiss those costs goodbye. Now picture this, you've got users working across different operating systems, Windows, Linux, and even Mac. And you might be thinking, how does that work in the cloud? Well, with Azure Files, it's a breeze. It provides seamless SMB file sharing, so whether your users are on Windows or Linux, they can access files effortlessly, just like they would in a traditional setup. But wait, it gets better. For Linux and Mac users, Azure Files also offers NFS shares, so everyone is covered no matter what platform they're on. Just a heads up, when you're setting up NFS shares, you'll need to use a premium tier storage account and make sure you've got a configured virtual network in place to control access. It's easy to do, and it ensures that everything runs smoothly and securely. So whether you're running Windows, Linux, or Mac, Azure Files makes file sharing simple, cost-effective, and reliable. It's all about boosting availability while keeping things hassle-free. Last but definitely not the least, let's talk about Azure Table Storage. Now, when I say rows and columns, you might think, oh, it must be like a relational database, right? Well, not quite. Azure Table Storage is more like your trusty filing cabinet, but with a twist. Each row in Azure Table Storage has a unique key, kind of like each drawer in your filing cabinet. But here's where things get interesting. It's not your typical relational database. There are no relationships, no stored procedures, and none of that complex database structure we talked about earlier. So what's the deal? Well, we're dealing with semi-structured data here, which means that columns can vary from row to row. Imagine your customer info table. One row might have a name, a phone number, and an address, while another row might have totally different columns. No rigid structure. And here's another cool thing, partitions. Think of them like organizing your filing cabinet into categories. Partitions help boost scalability and performance. So when you're searching for your data, you include that partition key, kind of searching within a specific category in your cabinet. This speeds things up and reduces the work your system has to do for reads and writes. Pretty neat, right? Now let's talk about the key system in Azure Table Storage. It's not like your usual DO key. Think of it more like a combination lock. You need two components, the partition key and the row key. The partition key is like your category label grouping similar files into one folder, and the row key is your unique identifier within that folder like a file's distinct name. Together, these two, the partition key and the row key, create a unique combination that ensures no two rows in the same partition share the same key. It's like giving each file its very own lock combination to keep things organized and easy to retrieve. I know that's a lot to take in. It's a bit like jumping into the deep end with all of this talk of keys and partitions. But don't worry, instead of just staring at slides, how about we log into the portal and create an Azure storage account together? I'll walk you through how to store data using all these awesome tools step by step. All right, let's jump back into the Azure portal where we're going to do our Azure storage demo. For this, I'm going to click on the Create a Resource button, and I'm going to look for Storage Account. And this time, the first one that we are going to be creating is this one, a storage account. And let's go ahead and hit Create on the storage account. As always, I'm going to first choose the resource group. So in the storage account, we're going to first add it to a resource group, as usual, for this resource. And then we're going to give the storage account a name. Let's call it blob for DP900. Let's keep this resource in the West Europe region. And select Azure Blob Storage or Azure Data Lake Storage Gen 2 as the primary service. For the performance, we are going to stick to the standard performance since this is just going to be a demo. But remember, we can use the premium tier for those NFC file shares that we spoke about. For the redundancy, we're going to choose the locally redundant storage. This is because, again, since it's a demo account, we do not want to create backups in other regions or other data centers. Locally redundant will suffice. So let's go to the next page. Now, the most important thing in this second page is going to be the hierarchical namespace. This is actually the feature that gives you an Azure Data Lake Storage Gen 2 account. If you leave this unchecked, it will give you a Azure Blob Storage account. And if it is checked, it will give you an Azure Data Lake Storage Gen 2 account. So I'm going to leave this unchecked for now because I want to create a blob storage and click Next. I'm going to keep the public access from all networks so that I can access the storage account. I'm not going to create any private endpoints. For the data protection, I'm going to uncheck all of the recovery options. This is good if you do want to have some recovery for any of these of your data, but for this demo, we're going to leave this unchecked. So let's go to the next page. We're not going to make any changes to the encryption type, keep all the default settings here. And then we're just going to go to review and create the storage account. So we can see all of the configurations we have set here and just hit create. So, all right, here we go. This one didn't take as long as our Azure SQL database, so it's ready. Let's go to the resource. And here we are in our storage account. And this is a brand new storage account, which doesn't have any data yet. So let's look at the different services we have here. So if I zoom in here, you can see I have containers, file shares, queues, and tables. So let's take a look at the containers first. So let's create a new container here. I'm going to name this products. Actually, let's change that and call that data and hit create. This is our first container, and we're going to put our products data inside this data container. So now we're going to move to the storage browser, which gives us the ability to make changes and add data, delete data, or update data into our container. Let's go to the blob containers, and here we can see our data container, which was just created. So let's move into the container, and here let's add a directory. So we're going to call this directory products. But before we create this directory, let's take a look at the virtual directory. This is a virtual directory. A virtual directory does not actually exist in Azure until you paste or upload blobs into it. To paste a blob into a virtual directory, copy the blob before creating the directory. So let's take a look at how this works. I'm going to hit OK. And let's go back to our root container data. And you can see we do not have that directory we just created. That's because it was a virtual directory. All right, let's upload some data. I'm going to browse for some files, and I have some product data available. So I'm going to select my product one file. And in the advanced section, I'm going to say upload to folder and create a new folder called products data. And then hit upload at the bottom. All right. Now you can see we have a directory created, and that's because we do have a blob inside this directory. If this directory was empty, we would not see this directory. But because we have a blob, we see the directory. All right. So let's go back to the containers under data storage. And let's go into the container. Let's go into our... Actually, let's check out the state of our folder here. And we have 3 dots, but if you click on these 3 dots, nothing happens because remember, this is a virtual directory, right? So we cannot have any settings at the directory level because it's a virtual directory. So that's a quick feature that I wanted to show you. So that's a little bit about blob storage. Now let's go back and take a look at how Azure Data Lake Storage Gen 2 works. For this, we are going to scroll down to this Data Lake Gen 2 upgrade setting available under settings. Just wanted to highlight this, Data Lake Gen 2 upgrade. And we have 3 steps here. So let's go through them one by one. The first step is to review the account changes before upgrading. So this is going to check if you have any features enabled which need to be disabled or anything like that. You just need to review your account changes and then also agree to the certain features need to be supported. So that's complete. The next step is the validation. So if there are any features that are not supported by ADLS Gen 2, these will be listed here in the validation stage. This can take a little bit of time. All right, there you go. Our validation has succeeded. We did not have any discrepancies, so we can move to the last step, which is upgrade the account. During this upgrade, the storage account will be offline, and the upgrade can take several hours to complete depending on how much data you have in the storage account. And we cannot revert back to a blob account after we have started this upgrade. All right, there we go. We have successfully upgraded our account to Data Lake Storage Gen 2. So let's go back to our containers. Let's take a look if our data container is still there. It looks like it's still there. We have our products data folder still here. And if we go inside this folder, we'll see our JSON files are also still here. There you go. We can see our JSON files. All right, so let's go back to our containers. And if I click these three dots, I'm actually supposed to see some options. But before we do that, let's upload some more data in this folder. So I'm going to upload the products2 file, JSON file. So let's do that from the storage browser. Let's go to blob containers, go to data, go to the products data folder, and upload the data here. So I'm going to upload my product2 file and just simply click on upload. There you go. I have my product2 JSON file available here. So now let's go to the data storage containers and verify that we have these two files in our container. And there you go. I can see these two files here. All right, so let's go back into our containers and to the products data folder. And now when I click on the three dots, I should see some options here because I have the hierarchical namespace enabled. And now this is in Azure Data Lake Storage Gen 2. So I can see the properties of this directory. I can see the permissions. I can see the owner who's a super user. I can see the name of the directory. And I can also set ACL properties and also generate SAS tokens. So this is because this is not a virtual directory anymore. This is a real directory that we have created inside our Azure Data Lake Storage Gen 2. All right. Next, let's move on to file shares. So I have my file shares available over here under data storage. That's what we're going to look at next. And the first thing we're going to do is create a new file share. So I'm just going to click on the plus new file share button, give a name for our file share. So I'm going to call it files. And let's keep it selected to transaction optimized and go to the next step. Here, I'm going to disable backup because I don't need backup since this is just a demo. And we will review and create our file share. It's just simple to create a file share, right? And now to connect this file share, you have a connect button available there. If I click the connect button, I will have three different user interfaces that I can connect this file share to. I can connect it to Windows, to Linux, or Mac OS. So I can choose what kind of authentication I want to use. Do I want to use Active Directory or Entra ID or storage account? And then also I can select which driver I want to link this up to in that Windows account. And then also I can go down and click on Show Script. Show script where I will see the script that I will need to run within that Windows machine to connect to this Azure file share. Okay. And with that, you will be able to access the Azure file share from that Windows machine. So we also have an option for Linux and for Mac OS. So that was a little bit on file shares. Let's go to our final service. All right, so let's go to our tables. And here we are going to create a new table. And I'm going to call the table products. Oh, and there was a space there, so I just remove that space and click OK, because we cannot add space to our table names. Here we have our new table called products. And then I'm going to go inside this table from my storage browser again. Select tables, and here I have my table available products. So now I'm going to go inside this table, and I'm going to add an entity. And this entity is going to have one as a partition key, one as a row key, and then I'm going to add a couple of properties. The first one being name, and I'm going to add the name widget. I'm going to add another property, and this one is going to be price. And I'm going to select double for the string, for the type of the data, and put 2.99. And I'm going to insert this entity. So you can see my entity available here. So if I go to my tables and go back into my products, you can see I have one record has been added. Let's go add another entity. And this time, I'm going to give partition key to be 1 and row key 2. Name is going to be knickknack. And price is going to be 1.99. And I'm going to add another property here, which is discontinued. And I'm going to have it as type Boolean and give it a true or false value, in this case, true. And I'm going to insert this entity. All right, so we have two records. One record has 4 attributes and another one has 5. And you can see the discontinued one is empty for the first record. And it's blank, and we only have a value for the second one. So this is a NoSQL option that we have from within our storage accounts. And with this, we have come to the end of our demo. Thank you, and I'll see you back in the presentation. Now that we've seen Azure Storage in action, let's dive into our next lesson in this session, Azure Cosmos DB. So you might be wondering what exactly is Azure Cosmos DB and why are organizations around the globe turning to it for their data storage needs? Well, let's break it down. In the world of database management, traditional relational databases have been the go-to solution for what feels like forever. Don't get me wrong, they're great in a lot of scenarios, but they can feel rigid and sometimes demand a lot when it comes to performance tuning. And in today's world, where data is constantly evolving, that kind of rigidity can be tough to manage. Azure Cosmos DB is part of the NoSQL database family. Unlike relational databases, NoSQL uses different models to store data like documents, graphs, key value stores, and column family stores. But what does that mean for you? In a word, flexibility, and scalability too, without sacrificing performance. One of the coolest features of Azure Cosmos DB is its support for multiple APIs. This means developers can interact with Cosmos DB using programming languages they're already familiar with, no matter how the data is stored behind the scenes. So whether you're working with SQL, MongoDB, Cassandra, or others, Cosmos DB has you covered. This flexibility is a game changer. And let's talk about performance, because that's the cornerstone of any effective database. Azure Cosmos DB uses indexes and partitioning to deliver lightning-fast read and write operations. Plus, it can scale seamlessly to handle massive amounts of data without needing constant migrations or infrastructure overhauls. That means that you can focus on your applications without worrying about whether your database can keep up. But Cosmos DB isn't just about speed and scalability, it's also about global accessibility. You get multi-region writes with just the click of a button. That means you or your organization can add Azure regions wherever they are needed. This global distribution ensures that users across the world can access their data through local replicas, creating a smooth, low-latency experience no matter where they are. Azure Cosmos DB frees your organization from the constraints of traditional databases and opens up a world of possibilities for data storage, management, and accessibility. Now, before we dive into the practical side of things, I want to loop back to those APIs I mentioned earlier. Developers can use their favorite programming languages to work with Cosmos DB regardless of how the data is structured. So let's take a closer look at some of those APIs that Azure Cosmos DB supports. First up, we have Azure Cosmos DB for NoSQL. Think of it as your Swiss Army knife for your data. It handles JSON document formats and speaks SQL, making it incredibly versatile for all kinds of data tasks. Whether you need a screwdriver or a can opener, NoSQL's got you covered with its multifunctional capabilities. Next, there's Azure Cosmos DB for MongoDB. This is like your chameleon friend who adapts to every environment. With MongoDB, data is stored in BSON, a binary version of JSON, and you can use MongoDB client libraries to interact with it in Cosmos DB. It seamlessly blends into whatever database environment you need, making data storage and management a breeze. Then we have Azure Cosmos DB for PostgreSQL. This one is like your librarian who keeps everything perfectly categorized and organized. PostgreSQL is a relational database wizard giving you the structure and organization you need to store data neatly, just like how a librarian knows exactly where every book belongs. Now let's talk about Azure Cosmos DB for Table. Imagine it as your speedy courier service for key value tables. It delivers what you need right when you need it with incredible speed and scalability. It's like having a delivery service that can bring you anything in your massive data warehouse faster than you can imagine. Moving on, we've got Azure Cosmos DB for Apache Cassandra. This one's your carpenter. It builds databases that are custom fit to your needs, with each piece able to look different depending on what you need to store. Just like a carpenter crafting each piece with care, Apache Cassandra handles distributed large-scale data with flexibility and precision. And finally, we step into the world of graphs with Azure Cosmos DB for Apache Gremlin. Think of this as your detective who maps out all the relationships and connections in your data. Whether it's people, places, or things, Gremlin helps you navigate the web of interactions like a detective solving a complex case with a detailed map of clues. Each of these APIs is a specialized tool designed to solve specific problems, whether it's managing documents, organizing relationships, or handling complex tables. Cosmos DB has a right solution to meet your needs. Now let's jump back into the portal one last time today, and I'll show you how to work with these incredible tools within Cosmos DB. All right, so we're back again in the Azure portal, and this time we're going to be creating an Azure Cosmos DB. So let's create a resource and let's look for Azure Cosmos DB. And it's exactly this first one that you see over here, which says Azure Cosmos DB, just to highlight it. And I'm going to hit the Create Cosmos DB, and we'll have a a couple of different options here, different APIs that we have with Cosmos DB. So we have the Cosmos DB for NoSQL. This is the one we're going to be using for this demo. We also have Azure Cosmos DB for MongoDB, along with others like Cosmos DB for Table, Cosmos DB for Apache Gremlin, Cosmos DB for Apache Cassandra, and Cosmos DB for PostgreSQL. For this demo, we're going to stick to Azure Cosmos DB for NoSQL. So let's create this. The first thing we're going to do, as usual, is add our resource group. And we're going to create an account name. So we're going to say for this one, it's going to be Cosmos DB for DP900. And we are going to try to find a region here that works in Europe. So we're going to stick to UK West in this case. So let me just find UK West. There you go, UK West. And I am going to keep this as provisioned throughput. I'm not going to apply the free tier discount, but you can if you want. I'm not going to apply it. And I'm going to go to the next, which is global distribution. I'm going to keep both of these as disabled, but these are really cool features you have for Cosmos DB, which is geo-redundancy and multi-region write. Super powerful features for Cosmos DB for global distribution. So if you have an application which you're using in multiple regions, having multi-region writes is really, really powerful because it gives you very low latency features there. In the networking tab, we're not going to make any changes here, and we're just going to click review and create. We're not going to make any changes to the rest of the tabs. So validation was successful, and we can create our Cosmos DB account. All right, so we have our resource. Let's go to our resource. And now that we have created Cosmos DB account, the first thing we have to do is create a container. In order to do that, we are going to go to the Data Explorer, which is an option we have right here. So I'm going to just highlight it. Oops, I'm just going to highlight it, the Data Explorer, right here. And in here, we have a little bit of a video that usually shows up. So you can use it to understand what Cosmos DB is. I'm just going to close this. And what we're going to do is we're going to click on this Launch Quick Start to create some a container with some sample data in it. So you can see this is already pre-populated sample DB for my database ID. I have sample container for my container ID. And we also have the partition key, category ID. And I'm not going to make any changes to the default settings here. I'm just going to go click on OK. Just going to give it a minute for it to actually create this container with some data in it. There you go. You can see our sample database and sample container getting created in the background. And there you go. Our sample data container has been created. I'm going to close this view sample data and let's explore this manually. I have my sample DB, which is already opened up. So I close it and open it. You can see this is my sample DB. Within my sample DB, I have a sample container. And within the container, I have my items. And you can see this is one of the items that you have here. I have ID, category names, SKU, name description, price, and tags. Now, these columns that you can see right at the end with the underscore, these are generated by Cosmos DB itself. So this is not columns that you, or attributes that you are creating and adding to the records. So here, let's create a new item here. Just to show you how to create a new item. So I have the new item button there. I'm just going to click it. Just want to show you the new item button. And here we are given an option for populating two attributes, ID and category ID. Why is that? Because when we created the sample DB, we actually gave it category ID as a partition key. All right. I've populated just 1, 2, 3, 4, 5, 6, 7 here for ID. And I'm just going to populate another random key here. But this is mandatory because it is a partition key value in your database. So let's create some additional attributes here. So let's give it, for example, a name. And I'm going to call it Road Helmet 45. And I do need to add a comma there. And then let's add another one, which is SKU. And I'm going to put a random SKU number there that I'm just going to create. End with a comma. And then I'm also going to add a description. And I'm going to say this product is called Road Helmet 45, and then end with the last quotes. So you see the backslashes that I've added just before the quotes, the double quotes. That's so that I can recognize those quotes and it doesn't end my string text there. Okay, and that is why I've added that backslash. Okay, the last attribute I'm going to put is the price. This doesn't need any quotes because this is actually text. So I'm just going to put the text right, the numerical value right in here. And that's it. I can add my new record. I'm just going to click on save, and that's going to add my new record. And you can see I've added, these columns were added automatically to my new record without me having to do anything, right? We haven't added this. These fields are going to be super helpful for Power BI to navigate and process the records. Now that we've added a record, let's go and see how to query this in the Data Explorer. So let's go to one of these options in the Data Explorer, right on top, to query the data. So I'm going to go navigate back to the Data Explorer and go into my items. And one of these options on the top are going to be to query, to create a new query, not open a query. There you go. So new SQL query, that's the option. The new SQL query option. Just want to highlight it here because it is difficult to find. And then I have a query already generated for me. So I can already execute this query. I'm just going to put the from C on the next line, and I'm going to add a where clause so that I can find the record that we just generated. So I'm going to say where C name includes the helmet word, and execute the query. So if I see the results of this query, I can scroll down, and you can see accessories helmets, and this is the one that we created just now, the Road Helmet 45. So that's the one we just added. So that's how you can see it's super easy to query our Cosmos DB data in this query editor. And with that, we're done with this demo. See you back in the presentation. Wow, that was really something. Cosmos DB always gets me fired up. It's so simple yet so powerful. Now, before we wrap up, let's take a quick moment to recap what we have covered until now. We laid the foundation by exploring the fundamentals of data. We talked about the different data types, how data is managed, and the roles that data professionals play in the modern data landscape. We also took a deep dive into relational data in Azure and ended with a look at non-relational data, including services like Azure Blob Storage and Azure Cosmos DB, and how to work with them. Thank you for joining us so far. We look forward to seeing you in the next session of the Microsoft Azure Virtual Training Day, Microsoft Azure Data Fundamentals event.